How's it going, folks? Let's see. Where do I need to orient? There we go. Morning, all. All right, so we're getting started. Welcome to my cave. I'll give you the grand tour. Ready? Yup, that's it. All right, so here we are starting our online version until school comes back in or the coronavirus basically kills us all. So, we're going to be starting with the immune system today. This is the next section. If you guys have any questions, please feel free to ask them right in the chat. I'll do my best to answer them as soon as I can. We're going to be looking, if you check out Schoology in the Wednesday tab, you should see that we have our full lineup for what we're going to be doing today, starting with the immune system, going over the basics for it. Then I got a couple of videos for you guys to watch. Hopefully I'm not too loud. All right, so getting started. The immune system. So I figured that this was a good idea for us to go into because, well, right now we're all kind of dealing with it, you know? So with this, you got to keep in mind that anytime you get sick, there are only two possibilities. Either you die or you beat it. One or the other. Every time you've gotten sick, this is exactly how it's worked. The end result has always been one of those two options. So while we start to panic and people buy all the toilet paper in the freaking land in order to, I don't know, shore up their supply in their home, here we are, and we're going to go into kind of how this whole thing works. So if you guys take a look for the immune system, you can see it up. Nope. There. Yeah, there. Now I'm pointing at it. And we're basically going to be talking about the difference between the specific immune and the non-specific. And we're going to start with the non-specific because overall it's, I'm going to argue, not quite as applicable. Like, there's a lot of things that the non-specific system deals with. In fact, it deals with everything. And then we'll talk about the specific. So, our non-specific immune system is going to be composed mostly of protective layers and protective responses. And what those are is those are parts of your body that are just designed to trap and kill anything that might be a pathogen or might be dangerous to you. Bacteria, virus, in some cases things like fungal spores, stuff like that, all of that's going to get trapped. Now the first layer of the immune system, the first non-specific thing to keep in mind is your skin, right? This nasty layer of lipid that we've got over our surface does a phenomenal job in stopping things from getting in. And what it does is it traps them. And when we look at our skin, if you don't shower or bathe for a little bit, you start to complain that, it's oily or greasy. What that is that's actually part of the defense. See, to us, it's just tiny little droplets of oil or grease, but to something like a bacteria or a fungus, it is a sea of tar, something that it can't possibly get through. And so, the oil on your skin helps to trap it and keep it in one place. Then we exude sweat, small amounts, and it dissolves the bacteria because sweat's an acid. How we doing? Everybody hearing me so far? I'm gonna take that as a yes. All right, good. So, rolling on. What you're seeing up in the upper left of the screen, I think it is, or I'm completely wrong, that happens too, is the immune response. Namely, we're talking about things like inflammation. And so, when something harmful manages to pierce the skin, that first layer of defense, it's going to automatically cause this. This is the non-specific response. So it's going to happen every single time. When a cat scratches you, when something just barely pricks at your skin, you're going to get inflammation. Swelling is actually fluid flowing into that area, swelling it up so that your white blood cells can easier move around to kill and eat up all of the little bacteria that are involved. Now, for most of you guys, you're all familiar with this. You've experienced it 100,000 times. For some of you, this may actually mean even more. Because if we take a look at things like asthma or allergies, what those are is that is the same thing that is your non-specific defense of your immune system. That is the inflammatory or inflammation response that is starting up both of those pathways. In the case of asthma, what it is it's something that shouldn't stress your body that causes it to stress. It causes your immune system to think that something's attacking it, so your airways swell up with additional fluid, white blood cells mob to the area in an attempt to kill anything that may have gotten in, and your response then is it's kind of harder to breathe. Allergies are the same idea, where pollen or non-dangerous spores in the air get breathed in, and once again, your immune response triggers and decides, I gotta kill it. And so it charges off. Obviously, neither of those are great for us. Alright, you guys have any questions about our non-specific? Because that's really about all there is to it. It's just about inflammation and understanding that that's the immune... Yeah, let me try that again. The immune system misrecognizing something that it shouldn't be bothered with. This guy's going to help us on the next part. Okay, so let's get on to the specific immune response. Now, this specific immune response, as you can see, is a good deal more complicated, but it's actually only using a couple of different pieces, and I apologize because, wow, this slide did not work well. Letters are where they shouldn't be. No problem. We'll make it work. Alright, so whenever the skin is broken and something can get by, what we're going to have happen is we are going to have some sort of pathogen, something that might cause harm, like coronavirus right now, start to get into the body. And I am going to simulate bacteria with all of these cute little things, right? So they've gotten into the body, they're now starting to damage the tissues, and what's going to happen is automatically your body is going to start to move macrophages into the area. Macrophages are big things that can eat a lot, like this chompy dragon. Can you tell that I stole my son's toys? And so, what the macrophages are going to do is literally move in and just start to do that. They're just going to move in and one by one chomp up and eat the different bacteria. And that's their job. That's literally the only thing that they do. Now, generally speaking, they're pretty good about it. And what they do is they keep little pieces, like you can see right here, hanging out of the dragon's mouth. And then they're going to take that piece and they're going to take it over to a T cell, which we will simulate by chompy little alligator here. Alright, so the T cell will then kind of meet with them and kind of get a taste. Find out what is that bit, what is that piece. If it knows what it is, then your T cell will now move off to a B cell, our egg. Comes up to the B cell, kind of says, hey, I know what it is, we've encountered this before, here's what we need to make. Now, your B cells have a single job, and that is to make antibodies, which I am representing with all of these little red beads. And basically, the B cell, once it knows what it needs to make, will make those antibodies and just kind of bleh, shoot them out. They will stick to the bacteria. They will bind to different receptors. And through that process, it is going to effectively render the bacteria inert. There's nothing more that they can do. Now, the slideshow that you see going on up in the background is all of those steps. And the following page after it that you're seeing now, this one explains what each one of those steps are, so that you guys can go over it, practice it, get an idea. How were the toys? You guys like that part? Huh? Oh, the delay on this thing is weird. I also went through and drew up the entire thing onto the whiteboard. Non-specific inflammation and how that happens. Good, I'm glad you like it. Morning, Caleb. And then the specific response there, which is for virus and bacteria, the invaders, whatever they may be, one or the other, will come in. The macrophages will eat them up, which is what we see here. They will then take pieces, share it with a T cell to get it identified. The T cell will then activate our B cell. The B cell will make the antibodies, and basically millions of them will flow into your blood. Today we do not have a lab. Tomorrow will be the lab. I know, right? That's good. My boy seems to really enjoy finding the toys for it, so we'll probably keep doing it. Now, in order to show you guys how antibodies work, I kind of did it up right here. If you look at the green thing, that's our invader, our bacteria. And as we've learned, the proteins along the outside of all bacteria have that certain shape, that tag. Well, if an antibody is right, then it's designed in the right shape to bind to those proteins. And that basically will stop the bacteria from being able to reproduce, be harmful, and now all of your macrophages have flags that tell them exactly where to go and exactly what to eat up. Pretty nifty. I've got 2 videos for you guys to watch today. The first one is a general overview of the immune system from Kurzgesagt. Oh, I'll absolutely show Gideon. I'll call him up here in a minute. But the first one is from Kurzgesagt, and that's, God, I'm never going to pronounce that right. And that's just an explanation of how the immune system works. And then the second one is specifically for the measles, which is from the same people. You're going to see and hear a lot of the same terms, but the measles is going to be a bit more accurate for what we're dealing with coronavirus, because the normal video is bacterial, and obviously we're not dealing with a bacterial problem. So, the following slide, if you take a look, goes over our macrophage, exactly what its job is, the T cell, what its job is, the B cell, what its job is. I kind of included pictures of each one of them working. The top picture is a macrophage actively eating a bacterium. The middle picture is T cells communicating, trying to figure out what those pieces are on a macrophage. That's the blue one. And then the very bottom one is the B cell starting to make the antibodies, which are just these little protein rockets, effectively. So that's going to be our goal for today. Just make sure that you watch those videos, that you go over, get these notes, and understand the basic immune response and the 3 important cell types that are involved in the specific response. Tomorrow we're going to have a lab. Copies of it are already online, so you are more than welcome to take a look ahead if you want to. I'll have directions for it. And we're going to start slow with this whole online version. I've got to figure out how to upload all this to YouTube. So, yeah, it's going to be a thing. Do you guys have any questions for me today? And while you're typing them, there's another good video from It's Okay to Be Smart about flattening the curve today. And they do a nice job towards the end of comparing our responses now to the responses of past pandemics that we've had in the last 100, 200 years, namely the Spanish flu in 1919. All right, hold on. Let me get the boy up here real quick for you guys. I'm going to remove this because if I yell for him in this microphone, y'all go in deaf. He's on his way. I think he's on. Hi, come here. Come here, buddy. Look right here. Say hi to everyone.
Hi,
Woo!
but I not see Ava.
No, you see all the names right here? Those are people who are watching us right now.
Oh,
Gideon, can you tell them to study their cells?
study this down.
Very good. Thank you, buddy.
I sit in my tongue.
Yes, you are sticking your tongue out. All right, buddy. We're going to finish up the stream. All right, there you go, guys. I promise you, every day I'll give you a glimpse of some level of 3-year-old crazy. All right, folks. If you're good, if there aren't any other questions, then we're going to log for today. We'll call this good. As we go, we'll probably build things up a little bit more as we have more time and we get more comfortable with the platform. So, ladies and gents, have a good one. I'll see you tomorrow at 11 o'clock.